Okay, welcome guys to the second video about solving the algorithms in Hackerrank. This time we will be making the climbing the leaderboard, which is a difficulty medium, and the point is to return the positions of a player given a specific player scores and ranking scores. Okay, so the game uses dense ranking. That means that when a player has the same score as in the rank, it's just the same position. Okay, let's explain better. Like for example, if we have we see here, all these players that have the same salary are within the same rank. Okay, that means that all of if the first, like we can see in here in the example, the first one is 100. So if 4 players have 100 points exactly, they are on the first position all. So therefore we have to just build the algorithm that will, given this specific format, that means we first receive a 7 and then the array of ranked positions, and then the player scores, which would be the next array. Okay, so then we have to return it also like an array, and as we can see, like first it returns 6 because when the player had 5 points, it was ranked as in the 6th position. When the player had 25 points, it was on the 4th position, right? Because first position would be 100 or more, second position would be between 100 and 50, third position would be between 50 and 40, and fourth position would be between 40 and 20. Then we have the same for the next one, second position, and finally he got 120 points, so it was in the first position because it's even higher than the highest ranked position. So let's start building things. Also, other thing I want to say is that I will build 2 algorithms, okay? 2 different algorithms. One is very simple, it's just basically 2 lines of code, but it has one problem. It's one performance problem, okay? That we'll discuss later. And then I will make, that's why this problem is categorized as medium, because you have to write a more elaborated algorithm to really make it performance, okay? So let's start. So the first one would be, since the scores, as we can see here, can be duplicated, we should build a set that don't have that duplicated codes. Okay, the easiest way to create an array without duplicates is to build it using a set, right? So we can say, for example, like post, like positions, and then we say spread a new set that receive as parameters the scores. Okay, therefore we will build an array that contains all the scores but without duplicates. And then we can say simply, directly, we can say, okay, and now we want to map all the scores that got a list and get the position, right? So how we would get that? So since also like the positions are opposite, right? Like the first one is the the first score is, let's say, the worst, no, always, and the last is the best. So we have to take the length of total positions, right? And then we will get, we will filter the one that is higher. So when B is higher than B, okay, and then we will get the length of this, right, plus 1. So basically what is going here is we are getting the length of the total positions, and then we are just subtracting to that to the total number of of scores that are less than less or equal than the score of Alice, right? Yeah, I guess we can do it also like without subtracting and just saying the ones that are less than. But okay, so yeah, you can just after play it as you want. But yeah, as we can see, it's working like for the test cases, right? It's okay, but there is a problem. That's why this algorithm is not simple, not easy, because if we submit this code, we see, oh, they are passing. Wow, nice. But there is one problem, is that these that are still loading, they will not pass because of time limits. Okay, it didn't terminate it because time is why? Because we can see like the input is an array of 200,000, right? So it's really big. And what's going here? First, we have to build a set, okay, that will take at least on. From that, we will spread. It's another on. Now here we want to map the values, and and here we have like for each value in Alice, we are also filtering. That's on to square, right? So yeah, so it's not efficient. So let's do the efficient one. The efficient one is much more elaborated, okay? So basically what we have to do is if we visualize a bit, the problem, we can see that this should be possible to solve it just in on, right? Just like going through the ranked array just once. Well, better say through the player array, but we need to probably like run over the whole, like in worst case we will go through the whole ranked array. So how this should work? Well, if we see what is our algorithm, like our human way to know the results. Well, basically we check, okay, the first point is 5, right? First this player got 5 points, so we have to find where, like in the ranked, there is a value that is less or equal than this 5. Okay, and we can see there is no value, so we directly can calculate the position, because we say, okay, all these are in front of our player. Okay, so for the next one, as well, I said it in the start, right? So for the next one, we just have to find the let's say the range between we can put this value. But what's happening here? Because these values are from worst to best, and the ranked is opposite, right? We have the first, the best, and then the last is the worst. So what happens if we do it opposite? Like we start from the best one from the player, we see 120. Okay, and the array, the best is 100, so the player has better score. That means that we will probably see that this is the first, so he's the first. So that's it. We don't have to travel all the array, and we can actually like keep track, like keep let's say a pointer in the array, right? To check the next one, the 50. Okay, so we will move now the array until we find 50 or less, and we found 50. That means this is the next position. This is the second position, because he got exactly the actually it should be the it's the second position. Yeah. Okay, because it's the second highest. And again, now we move to the next one, 25, right? And we will just continue. We will just like continue moving the indexes carefully, and we don't have to run over the array many times. So I think it's the most efficient way. So we will write this. First, we will have to have like results, where we will have our results. What will be an array of results. So this is the only auxiliary memory we will need. And then we will have to keep track of the score index. Okay, we'll start at 0, and we will keep track also the position, right? So the first will be the first one, because if the values are the same, right, like we have there the 100, if we have many times the same value, we don't want the position to increase. The position should stay the same. Okay, then we will iterate over the Alice score, but from the end, right? So we will start from Alice length -1, and this until we get to the first one, and minus, okay, to go from the end to the start. Okay, and now what we will do, we will check, well, if the score we are checking is less or equal than the Alice score. So we will say score inks is less or equal than Alice score. Okay, if this is happening, we will just push the result, which will be the post. Okay, what happens if not? Then we have to find, okay, we have to keep moving the scores index until we find the proper value, right? So we have to keep track that we are not in the end first, and we have to check if the value is higher than the Alice one, right? So we until we find a value that is less or equal than the Alice one. So while this is not happening, we will have to, well, before this if, I want to just say that we will increase, okay, like at the end, we will increase the scores inks by 1, because we need to move that, and we need to move the position, right? But we will move only the position in case that our scores inks is different than the scores inks -1. Okay, because if it's the same, we don't want to increase the position. Okay, and when we found this, we will just say if scores inks is less than the Alice one, yeah, because we found it, then we will push it. And if not, okay, that means that we are on the last position. So that means we haven't found it, so we have to push position +1. Like for example, in this case, we can see like the player rank was 5, and in the ranked array we don't have 5, right? The last one is 10, so we already surpassed the whole array, and we haven't found it, so we have to push like the position +1. Okay, and at the end we will just have to reverse the array, because we were pushing the results, but in the opposite way, right? From the end to the start, not from the start to the end. And therefore it should work. Okay, it's not running because I have some error here. score. Yeah, this is score inks, not scores inks. I have it again wrong. And again here I see it. Okay, so the error was here, so we have to like check we are on the before the last one, right? When the score index is before the last one. So now it's working. We can submit the code and it's passing, so everything is fine. Thank you guys and see you on the next one.